Good evening, everyone. Welcome back to another plant episode of Carlton Carnivores. I've got a special group that I'd like to share with you guys that you've probably seen. If you follow me on social media, you've seen photos of these guys here and there. They're not a group that I have a huge number of compared to a lot of the other carnivores that I work with, but they're a fascinating group to grow, and they are quite colorful and interesting in their own right, and maybe often overlooked because many of the ones that are out there right now are often really expensive and not really sold towards, say, beginners. So they're often only really picked up once people get really proficient in growing carnivorous plants. And so sometimes are a little bit scared to try them because there's a lot of stories about how they can be really difficult to grow. This is a group of carnivores that is closely related to the familiar American pitcher plant Sarracenia. Their sister group, let's pick a good one here, the Heliamphora. These are what are known as the South American or marsh pitcher plants. They are a group of carnivores that are actually sister genetically to the Sarracenia in the family Sarraceniaceae. These guys diverged from the North American pitcher plants about somewhere between 18 and 20 million years ago, and ended up being isolated in South America, in northern South America, on the plateaus that existed there. And as those plateaus have eroded away and left behind what are now called tepuis, the Table Mountains of Venezuela, Brazil, Guyana, and so on, these guys ended up being isolated on top of those mountains, and from there, the isolation on each of those separate peaks resulted in a diversification into a number of species. The tepuis are a very interesting environment because they are tropical. They sit almost on the equator, so the conditions there, the climate, is pretty much the same year-round. Very rainy, fairly warm conditions during the day, but because these are very high elevation mountains, the tops of them can be anywhere from 3 to 8,000 plus feet in elevation. It is often very cool up there as well. So this is a constantly cool, rainy, wet, humid environment existing kind of in the cloud range. So other places where you have mountains that kind of slope up and you get cloud forests, these guys, the Table Mountains, have extremely sheer sides. So you go from the base of them, which is kind of lowland tropical forest, and you go up the sides and immediately hit cloud forest. Extremely isolated, extremely unique climate environment. And because they are so high elevation, because it is so rainy there, and the rocks that they are built out of are extremely tough, there's not a lot of soil up there either, so all that rain just kind of washes away whatever does develop, and so it is a very barren, very low nutrient environment in many places, which is kind of a perfect environment for carnivorous plants to develop. These guys take advantage of places where other plants can't grow, of course. So no soil means it's open, it's nice and sunny, at least when the sun pokes through the clouds there. And these guys, of course, have other ways of gathering nutrients. They still get energy like other plants, photosynthesis from the sun, but they gain their micronutrients, things like nitrogen and iron and phosphorus and magnesium and so on, from other living organisms, mostly insects. So Heliamphora are kind of unique. Like, again, they're related to Sarracenia and Darlingtonia, so the North American pitcher plant genera, and so they have kind of a similar structure as well, and you can kind of see it a little bit when you look at these pictures. Like Sarracenia, they've got this little wing, this ala, that runs right down the front of the pitcher, and then it opens up into the mouth, so the pitcher formed from, quite simply, a leaf that kind of rolled up on itself to form a tube, and then, like Sarracenia, having a lid over the top of the pitcher, a lot of these guys have this little remnant that's left. It doesn't really cover the pitcher at all, but we'll get to that in a second. So this structure, of course, is open and it allows things to fall inside. If you look on the interior of a lot of these guys, and I'll try and show a close-up here, you'll notice that the upper portions of the trap are covered in these downward pointing hairs. And so those point, of course, into the interior of the pitcher, and eventually it comes down to where there's this little hip in the pitcher. The hairs stop above that, and below you get a waxy and digestive zone. So little waxy scales that insects can't really climb up on. Some species, those wax scales actually continue all the way up into the opening, the top of the pitcher, and that's actually all they use to capture prey. Some of these are actually ways you can use to distinguish between different species, whether they really have those hairs or just the waxy scales, or sometimes nothing at all. But down here is where you have the digestive zone. Now, a lot of Heliamphora are a bit contentious in the carnivorous plant group because there's only a couple of species, like Heliamphora taeti, that are actually proven to produce their own digestive enzymes to break down the insects that fall in here and can't get out. The rest of these guys, and this is where this big open uncovered top of the pitcher comes from, they rely on mutualism, symbioses with other organisms. So small like midgefly larvae or bacteria and fungi that might come in naturally on the insects or just in from the environment that go in there and break down the insects that they've caught. So while a couple of species produce enzymes, and indeed with more testing we may find that a lot of these guys actually produce their own enzymes, they also rely heavily on mutualistic organisms that live within the pitchers as well. And that's good because since they are open to the environment, it would be kind of costly to be constantly producing their own digestive enzymes just for it to get flushed out by the rain. But these guys kind of have a special way of dealing with that as well. So even the ones that do produce their own digestive enzymes, they're able to retain those and not have to worry about the rain despite being open because of a special structure, how they've actually formed here. Now, again, I'll have to try and bring in a close-up on this. Within this ala, the wing that runs up the front of the pitcher, if you look closely at it, usually you'll notice on most species it's actually split in two. And up near the top where the wing disappears and it splits out into the mouth of the pitcher, some species, they just kind of have this slit that runs down the front of the pitcher. Others, it joins up and then there's this tiny hole right in the top of those two wings that actually leads into the pitcher just above the digestive zone. That's basically a drainage mechanism. So these guys can get rained on, torrentially deluged, fill completely up with water, and within a few seconds to a couple minutes, all of that excess water will just drain right out of the pitcher so that it doesn't hamper the functioning of the trap. All that water that would allow insects to just swim to the edge and climb out gets drained away, so the top part is still acting like the trap that it should, while everything below that drainage hole or the bottom of the drainage slit stays in there. So the concentrated digestive fluids, the captured insects and everything stays inside the pitcher and gets digested, gets used up by the plant. And so that way these guys can survive an environment that is incredibly harsh, very cool temperatures, extremely exposed, extremely rainy, and very, very low nutrient. These are adapted perfectly to that kind of environment. Now the tepuis, again, there are a number of these table mountains that are found in South America. So a lot of these guys have developed in isolation from each other, different populations on different mountains, and so that has allowed them to give rise to a number of new species. And indeed, there might be a lot of species that we haven't even discovered yet because so many of the table mountains down there are basically inaccessible right now. It's really hard to get to even some of the ones that have been explored already because you have to have special equipment. Either you have to be able to take a helicopter up to fly to the top of these mountains and then hope you can find an open enough area where you're also not going to squish something important because there are so many endemics on these sky islands. So there might be a lot of species that are completely unknown still simply because we haven't gotten to those mountains. But the ones that we have gotten to, we have found just under 24 species right now that are described, and a few more that are still in the process of being analyzed for description. So these guys, they're quite variable in appearance. Again, you have some like this is, again, what is called Heliamphora nutans. Some people do believe that this quote-unquote giant form might actually be a natural hybrid, nutans cross glabra. And this is a fairly large, tall, pictured species. There's a few different species like that. Some of the ones that I have are still quite immature. Like I do have Heliamphora tati here. This will eventually become one of the largest species with traps up to 20 inches tall. Another close relative to that is Heliamphora ionaci, who's starting to reach a size where he might reach maturity soon. I might see mature pitchers. Again, they can produce pitchers almost 20 inches tall, and in the case of tati, will actually form stems over time, so the entire plant may reach 5+ feet high. Other similar ones, this is one of my favorites. This is Heliamphora niblinae, named after Niblina massif, the Niblina tepui down there, where this is mostly endemic to. Some of these species are found only on one tepui. Others you may have different populations that have managed to jump from one tepui to another within kind of a group of the Table Mountains. So these guys are some of the large pictured species. They're adapted for capturing pretty large amounts of food and dealing with fairly stable conditions. These might survive in slightly more lush areas where a bit more soil has built up, and so there's more plants they have to compete with. So they make pitchers that get up above that. And as you can see, they make some absolutely gorgeous colors too. The tops of the pitchers often develop these red colors for attraction, and that tip up here that I mentioned earlier, that is called the nectar spoon. So what is the lid in like Sarracenia has become just this little spoon covered in nectar glands underneath, and that provides an attraction mechanism as well. All that nectar attracts the insects. They're climbing around in there. Eventually they might touch the lower portions of the mouth here and slip in. Now other species aren't quite so large. You have some kind of intermediate species as well, like say Heliamphora exappendiculata. This one, the nectar spoon, is actually embedded within the exterior of the pitcher rim, so it's not sticking up above the plant, it's actually within the rim of the pitcher. Very interesting. Folliculata is very similar. So these guys get kind of an intermediate size. They might produce pitchers 8, maybe 10 inches tall. And then you have miniature species, like Heliamphora pulchella. This one I have is still fairly young. This is what they start out as, seedlings. They have these very odd, almost Sarracenia-esque like pitchers. They have a very similar shape, which kind of shows you, there's a phrase, ontogeny reflects phylogeny. So ontogeny means like young, underdeveloped traits. So looking at juvenile plants can sometimes tell you what they're closely related to, and these look a lot like Sarracenia seedlings. So he'll grow up eventually to be of similar size to, pull this one out, these guys. Now trying to hold it about next to my head here, you can see this is Heliamphora minor. Minor, of course, means small. And so this is a fully mature plant. You can tell because it's got these flower stalks that are hanging all over the place, and we'll get to those in a second. He only grows about 4 to 6 inches tall at most. So plants that range from like the very, very open adapted species like these guys that grow best in very, very open environments and will just carpet the ground in pitchers over time. They're also very long-lived. A plant like this has taken about 2 years to spread out from about 2 growth points when I last divided it, and it's gotten to this. They can live potentially for centuries, and so you can get just carpets of pitchers several feet across on really mature plants up there. But some of them just don't get very big. So that's one version. This is another version that is just starting to reach up to size. This is also Heliamphora minor. This is minor pilosa. I'll try to get a little close up here as well. This differs from the typical minor because it's got much longer hairs on the interior, and in some forms, this one is barely showing it, but some forms also show a lot of hairs on the exterior, hence pilos, hairy. So they don't get very big. So these ones are adapted for very open environments. So you have this massive range of sizes and shapes that are adapted for different microhabitats, different niches on the tepuis. And often on each of these tepuis, you might have one or two species that are really tall, like Tadei, Nebline, Newtons, and so on. And you may have others on the same tepui that are shorter. So different species that are utilizing two different niches within the same environment. And you often won't find two really large species right next to each other. In a couple places, you might have one or two that do kind of overlap, but overall they're relatively separated. But you will find some of the larger and smaller species often fairly close to each other. So they are able to kind of partition those niches out among them. Now, as I showed you earlier, and as I can kind of hold up here, they are, of course, like all carnivores, flowering plants. Now, does this have a good... Yes, it does. So with Heliamphora, the flower stalk is kind of unique, because if you look down here, the flower stalk actually has started way down at the base down here, and it's grown up, and this is actually a bract right here. This is not a true quote-unquote leaf. This is modified, but is still developed as a pitcher. So oftentimes, as these guys develop, it's actually kind of shown here as well. You can see the flower stalk started way down there, but then on the bracts, all right, the modified leaves that are protecting the flowers as they develop, sometimes they develop pitchers as well, because the original structure from which these developed was simply a leaf. Same goes for flowers. Actually, this is all modified leaves that have been changed into reproductive parts. But these guys, they develop a stalk, and it grows up. Let go of that, sir. Thank you. They grow up, and it produces one to several buds over time. Set that back down again. Now these buds start out, they're all closed up, protecting the reproductive organs within, and as they develop, they dangle kind of pendulous upside down like that. And as they open up and develop, the petals usually start out bright white or sometimes with a bit of a pinkish tone, and that's what first attracts insects to them. They produce a little bit of nectar to bring them in. Insects will come in, and these guys, they have a separation in development between the male and female parts in the flower. So it is a hermaphroditic flower. It has both parts, but the female part, the pistil, matures first. And in fact, before the flower even fully opens, the pistil is actually usually mature. And so that is awaiting to receive pollen, and it has to receive pollen from a different flower, oftentimes from a different plant, so that promotes cross-pollination, which is better genetically for these guys. Then, after that's been pollinated, the pistil becomes non-receptive, and all of the anthers around here mature next. And the anthers are kind of unique because they don't just have pollen sitting out to be like wiped off with ease or anything. They actually require what's called buzz pollination. So small insects like a bee or a fly or something like that comes in here. The vibration of the wings will actually tickle those anthers, and the pollen will kind of slide down tubes to the tip of the anther and fall out as the insect is buzzing against it, and so covers the insect in pollen, has that carried away somewhere else. You can kind of mimic that with, say, a tuning fork, or even, if you do it right, sometimes you can just flick it with a toothpick, and that'll kind of knock the pollen down the tube and onto whatever surface you might be collecting the pollen on. I'll admit I haven't had success with producing seeds from these guys, but if you do it right, again, you have to have a younger flower, which has the mature female part, and an older flower, which is producing pollen, ripe at the same time so that you can cross them. You take the pollen from the old flower and put it onto the stigma of the young flower, and the ovary, over a couple of weeks, or actually a couple of months, will slowly develop and then release these kind of roundish, papery, brown-looking seeds. And those then take a few months to sprout into seedlings that, again, they start out a little smaller than this, but that's roughly what they'll start out looking like. Two normal leaves, cotyledons, and then they produce these immature pitchers for the first couple years of their life. And then after a couple years, you start developing mature pitchers. This is Heliamphora chimentensis from Chimanta tepui, or Chimanta, depending on how you say it. And he is only just beginning to produce mature pitchers. There's one that's starting to develop right there. There's another one back here that is producing semi-mature looking pitchers. But even then, they start producing those mature pitchers at a fairly small size, it'll take another couple of years for that plant to reach maturity. So these are very slow growing plants. That's one thing that maybe puts some people off from growing them, is that they are fairly slow growing. And it's already falling off here, so I'm just going to pull it off to demonstrate. The pitchers are really, really brittle. They are very, very sturdy, and they snap very easily. This is just going to be one that'll be thrown away, so I'm just using it for demonstration. But they break very easily, and they break almost like a hard cardboard, or like a soft plastic or a rigid plastic. And so they're easily damaged. So this kind of puts some people off of growing them sometimes because, again, slow growing, they have that very specific climatic environment that they expect, and all of that together makes them perhaps a somewhat challenging group of plants to grow. But in general, if you can get the conditions right, they're actually quite straightforward. So again, they are fairly cold-loving plants. All right, this is a cultivar here. This is an unknown hybrid cultivar called Red Mambo. The parentage is not quite known, but it's a beautiful little plant. Sometimes the hybrids are actually much easier to grow. I've got a couple of them here, minor cross Newtons. That's one I've got. The hybrids are a little more tolerant because they're mixing genes from two different plants, so they might tolerate slightly warmer conditions. But generally, what you want to do is give these guys very cool but very bright conditions with a decent amount of humidity. So one of the easiest ways to do that is, like, if you have a basement that stays fairly cool, you set up a little tiny tent in there with a bright light overhead so that the cool of that basement environment will keep the temperatures down in general. And at night, if you need to get cooler, throw in a heat pack, or if you have a bigger setup like this, have an evaporative cooler or a small portable air conditioning unit. So temperatures should stay cool basically all the time. And in fact, if it stays cool all the time rather than fluctuating high during the day and lower at night, you can also get away with growing these guys at more moderate temperatures just throughout. So if you can keep temperatures below 70 degrees at all times, the temperature doesn't really have to change too much, and these guys will still tolerate that because they're not getting overloaded by energy from the warmer conditions. So, but generally, temperatures, if you can keep temperatures below about 85 degrees Fahrenheit during the day, and then if it's warm like that, cooling down to the upper 60 or lower 60s, upper 50s Fahrenheit at night, that is about the temperature that these guys want. And then getting a light that is as close to full sun as you can possibly provide, because again, they grow in very exposed environments on these tepuis, so they're constantly exposed to extremely bright sun, and because it's high elevation, very strong sunlight. So if you provide a little bit of ultraviolet exposure, you might also increase the coloration on these guys, because the red is not just an attractor for insects, it also acts as kind of a sunscreen for the plants. So if there's more UV light coming in, the color of the pictures is also probably going to end up enhanced as well. So again, that's not required, and certainly I don't provide that necessarily unless there's like a little bit that's incidentally made by some of the lights. But the brighter the lights, the better, and the more color you'll get. If the lights are not bright, you will end up with etiolated pictures. All right, the wings on the front will kind of get exaggerated. The actual tube of the pitcher will shrink, and the mouth will open up really broad and exaggerated because the plant is focusing on trying to capture sunlight more than it is trying to worry about capturing nutrients, because the energy from sunlight is more important to the plant than those micronutrients are, because it can always recycle most of that and get a little bit at least from the soil. The soil itself, these guys grow kind of like a combination between their relatives Sarracenia and Darlingtonia and Highland Nepenthes. So a good mix for these guys is very similar to, like Nepenthes, a sphagnum and perlite or even pure sphagnum mix, so that it retains a lot of moisture. And then I grow in little trays or cups and containers in the base so that it's constantly holding moisture. Nepenthes don't like sitting in water usually. These guys do like that. Because again, up there it is raining all the time. There is water that is collecting in channels and pockets where these guys tend to grow, where a little bit of debris and soil does collect. So their soil is often saturated and wet. A little bit of aeration can sometimes be good just to help keep the roots healthy, so allowing that to dry out on occasion. Not completely. Don't let the top start to dry. It should always feel pretty moist up here. But keeping it at least damp, usually wet, letting it dry occasionally so that air runs through the pot helps these guys. And then what you can also do is grow them with live sphagnum. This kind of helps tell you whether or not the soil is wet enough. As long as the sphagnum looks good, then the soil is moist. And if the sphagnum is healthy, then you know that there's not too much nutrients building up in the soil either, because too much nutrient buildup, like tannins and actual like nitrogen and phosphorus and so on, building up in the soil will burn the roots and harm these guys. And the roots are just about as delicate as the pitchers are. If you unpot one of these guys, the roots are quite long, but they're also extremely brittle, so they break readily. Don't let that scare you too much if you're repotting them. If you break a few, it's fine. Just try and be delicate with most of them. Be gentle when repotting, because you put them back in and you make sure that they're moist. New roots will grow after time. You'll just see the plant stall for a month or two afterwards. And so yeah, wet soil, cool temperatures, and then a moderate amount of humidity. These guys do not really like to dry out either. I keep them in the back corner of my Highland tent where it's kind of close to the walls of the basement, where the humidity is kind of being kept in the area a lot better than near the front of the tent. So these guys are always in at least 50 to 70% humidity. So that's pretty stable, pretty constant. So these guys never dry out, because if you get them in lower humidity, you may see the edges of the pitchers crisp up a little bit. Now, some species like Heliamphora minor, Heliamphora heterodoxa, and some of their hybrids will tolerate warmer temperatures and lower humidity than others, so those are always good for starter plants for people. Or there is one intermediate / lowland species, Heliamphora ciliata. It grows on the Grand Sabana, the kind of lowland savannas below the tepuis, so it tolerates much warmer conditions as well. It can grow with the rest in fairly cool conditions, but you might see it grow a little bit faster even, maybe a little happier in warmer conditions that might be more conducive to most people's growing conditions. So more household, as long as you can provide a little more humidity for that guy, because again, the lowlands, they're going to be fairly humid in South America. Now they're fairly easy to divide and repot as well. As these guys grow up, they naturally produce offshoots from each other. See if I've got one that shows it off really well here. We'll bring up Heliamphora nibline again. So you can see the main plant up here, big, beautiful. And then there's this second guy right here. He grew up from a section between the pitchers. There's little nodes in between each pitcher, and if that activates before the pitcher dies off, you might see a new plant start to grow out. So this is a separate, actually a couple of different growth points here that are starting to grow in their own direction. Now that's going to take at least a few months to get enough new leaves out and start setting out its own roots before it could actually be considered its own established separate plant. Before that point, it's just feeding off the root system that the rest of the plant is working on. But once it grows out far enough, and you'll usually be able to see that if you look at the base of the traps where the rhizome, the underground stem, starts to split between the two, if you see new roots coming off of the new growth point, you can actually go in and either cut or gently just break the connection between the rhizomes apart. If you've let plants grow long enough, like I have with the Heliamphora nutans, all those growth points will kind of have separated themselves over time. So they're all growing in separate places in the pot, and so they become their own plants on their own, and you can just unpot the whole thing, just tease apart the roots that are going to be tangled below, and then plant each of those into their own separate containers. So again, there's a lot of variety with these guys. There is some touchiness, especially with some of the larger species like Nibline, Ionoci, elongata. They can be fairly touchy plants because they like much cooler conditions than the rest, maybe a little more humid because they get larger. They expect a little more stability in the environment. Species, again, smaller ones like Pulchella, Minor, Heterodoxa, are a lot more tolerant of variable conditions, so they're great for more beginner plants. But that just kind of illustrates there's a lot of diversity in this group. There are plants for the beginners, there are plants for more expert growers as well. And all sorts of different shapes and color versions that you can find in these guys. There's black versions of Heliamphora minor. There's Heliamphora purpurascens, which gets really nice red-purple coloring. There's weird ones like Exapendiculata or Sarracenoides, which kind of has the lid fused with the back of the pitcher as it grows up. Mine is still young, so it's not really showing a lot of it yet, but these semi-mature pitchers here, you can see they just kind of come up, and then the nectar spoon is fused right with the back of the pitcher, so it's not really delineated from that, so it just looks like a big hood. Hence why it's named Sarracenoides. It looks almost like it has a Sarracenia-type lid developing off the back. So there's lots of variety to work with these guys. And again, the conditions that they grow in are somewhat similar to Nepenthes, saving that you keep them a little bit wetter. So if you grow Highland Nepenthes, you can grow these guys. Now that is about all that I have for these. If you have any questions, if there's a detail that I've missed, you can always leave a question in the comments below. Also, if you'd like to leave a suggestion for plants that you might want to see in the future, if you want me to deep dive on a specific species here or a different group of plants or some other detail, you can always let me know in those comments. If you'd like to help support educational materials like these videos or the blog articles that I do and so on, consider becoming a member at patreon.com/hcarlton. Members there get early access to the videos. They get the earliest notices for when I release new plants on the website at carltoncarnivores.com. They will get notice for new items before I put them on the website. You also get the monthly seed contests that I do. Those might be for pitcher plant seeds that I produce, or Drosera, or Biblis, or sometimes some of the odd wildflowers that I work with. I've got all sorts of things that I will offer. If you don't want to subscribe to a monthly donation like that, you can always do one-time things through either Patreon, or I've also got a Ko-fi account. The link for that will be in the description below. You can also buy the plants again, and sometimes young animals like the reptiles I've got available for sale right now through the website at carltoncarnivores.com, or merchandise at Teespring. Again, all those links will be below. If you can't support via monetary donation, then simply helping through giving attention to the channel here or other social media channels really does help. So watching these videos all the way through, liking them, leaving comments, subscribing to the channel so that you get notices for other things coming up. All of that really does help build the business here and help support it. And sharing videos so that others can watch also really does help. And of course, if you'd like to see more photos and videos and stuff, you'd like to find more information, there's the database with species files on the website, and I'm always posting photos and such on social media, Instagram, TikTok, and Facebook at Carlton Carnivores. But until next time, I'm Hawken Carlton, and this is Carlton Carnivores.